Good morning, students. So today's topic we are going to discuss is surface chemistry. Are you able to see the screen? Okay, so we'll start with the topic surface chemistry. Okay, so what is surface chemistry? What do you mean by surface chemistry? So it is referred to the study of the phenomena that is occurring at the surfaces of the substances. Okay, so we are discussing about the what is surface chemistry? It is nothing but it is referred to the study of the phenomena which is occurring at the surfaces of the substances. Okay, so these surface chemistry, it is used in day-to-day life. Okay, it is used in day-to-day life. So it mainly deals about the study or types of surface phenomena. Okay, so we'll start with some of the definitions. So first we'll say adsorption. Okay, so what is absorption? So absorption, it is a phenomena in which one substance enters into another. Okay, it enters into the another and gets uniformly distributed toward the bulk of another substance. Okay, for example, your sponge. Okay, your sponge is taken. So what is done? So this sponge is being what they have transferred it to a beaker containing water. Okay, so what is happening? So the water, okay, water which is uniformly distributed, it is been, what happens? It gets absorbed on this particular sponge. So it is a phenomena in which one substance enters into the another substance and gets uniformly distributed throughout the bulk of another substance. Absorption phenomena. Next is adsorption. Okay, next is adsorption. What do you mean by adsorption now? So it is a phenomena in which one substance accumulates on the surface of another substance in higher concentration. Okay, so it is a phenomena in which substance accumulates on the surface of another substance in higher concentration. For example, chalk and board. Okay, for example, chalk and board. What happens? Chalk, it gets absorbed. Okay, it gets absorbed on the board. So it is a phenomena in which one substance, it gets accumulates on the surface of another substance in higher concentration. So the example here given is of chalk and board. So your chalk, it gets absorbed on the surface of the board in higher concentration. Okay. So absorb it. Now in between this chalk and board, this chalk is said to be adsorbate. Okay, what do you mean by adsorbate? The substance which is being adsorbed. So adsorb. Okay, so your chalk is getting adsorbed on the board. So it is called as absorbate. And adsorbent, what do you mean by adsorbent? The substance which adsorbs. Okay, it means your board. Board, what is it is doing? It is absorbing your chalk. Okay, okay. So it is said to be adsorbent. So adsorbate is the chalk and absorbent is your board. So the substance which is being absorbed is the chalk, and the substance which adsorbs, okay, adsorbs is your board. So what is the, so remember the terms, what is adsorption, adsorbate and absorbent. Okay, next, desorption. Okay, what do you mean by desorptions? So the removal of adsorbed substances from the surface is called as desorption. So when you remove the okay, removal of adsorbed substances from the surface is called as desorption. What do you mean by sorption? When adsorption and absorption occur simultaneously. Okay, so these are some of the important definitions. So desorption is what? When you remove. Okay, when you remove the adsorbed substances from the surface is called as desorption. What is sorption? When adsorption and absorption occur simultaneously, then it occurs sorption. Okay. So now so there are two types of sorptions. One is physioption and chemioption. So we are going to discuss what are the main differences between these two. Okay. So first is, what is physioption? The molecules here in physioption are they are attracted to the surface simply by van der Waals forces. Okay, so you know van der Waals forces are weak forces. So here in physioption, what happened? the molecules here, they are attracted to the surface by van der Waals forces. And in chemisorption, the molecules here are held to the surface by chemical bonds. So you know chemical bonds are stronger forces than compared to your van der Waals forces. Okay. So the molecules here are held to the surface by chemical bonds forming the surface compound. So physioption, they are held by weak forces like van der Waals forces. Chemisorption, it is the molecules held are by chemical bonds. So here physioption, it is reversible, and chemisorption, it is irreversible. Okay. Then physioption, it occurs appreciably only at low temperature. So here the temperature factor, it occurs only at low temperature and it decreases with the increase in temperature. So if you try to increase the temperature, what will happen? The physioption, it goes on decreasing. Okay, it decreases the property. So it occurs only at low temperature. Then chemisorption, it first increases. Okay, it first increases and then decreases with the temperature. Okay, so these are the differences. So it does not require any activation energy. So what is activation energy? We have seen in the last class. So for physioption, it does not require any activation energy. For chemisorption to occur, it requires an activation energy. Okay, so we'll see some of the questions based on this. So which of the following is not a characteristics of chemisorption? Yes, which of the following is not the characteristics of chemisorption? Try to answer. So based on the differences, okay, we have seen the differences between the two, physioption and chemisorption. So which is not the characteristics of chemisorption? Yes, which is not a characteristics of chemisorption? Yes. So adsorption may be multimolecular. Okay, multimolecular layer, that is A. Yes. Rakshita, Monica, Akash. Yes, it is correct. So it is A. Okay, the answer is A. Why it is A? Because in chemisorption, the adsorption is unimolecular. Okay, it is unimolecular. It is unimolecular. So adsorption, it is maybe multimolecular is a wrong characteristics of chemisorption. Okay. So next, rate of physioption increases with. So what happens with rate of this physioption increases with? Rate of physioption increases with. How the rate increases? How the rate increases? Yes. Physioption. We are talking about physioption. Yes. Yes, see here, this point, physioption, what happens? Rate increases with. So what happens? Yes. So the answer is A. Yes, A. Okay. So what will happen? Rate of physioption increases with decrease in temperature. Okay. So if you decrease the temperature only at low temperature, the rate will be more. Okay. So this is the correct. So what is our correct answer? It is A. I hope you have got the answer. So it is what? It is A. Okay. So decrease in temperature. So rate of physioption, it increases with the decrease in temperature. Okay. So it is the answer is A. Next, the term sorption stands for. What do you mean by sorption? We have seen this. What does the term sorption means? Yes. What does the mean sorption means? Sorption stands for what? Yes. Damini, Harshita, Nandish, Kumar. Yes, it is C. Okay, it is C. Both adsorption and adsorption takes place simultaneously. Yes, correct. So we'll go for the next one. So what are the factors which are affecting the adsorption? So there are two things which are required for adsorption are, one is adsorbate, another is adsorbent. So these are mainly which is required for the adsorption to occur. Now what are the factors? So first is the nature of adsorbent. Okay, so the factors which affect the adsorption, the first is nature of adsorbent. Next is nature of adsorbate. Okay, nature of adsorbate. Next is pressure. Okay, then is temperature. So these are the factors which are required. These are the factors which are required for the adsorption. So factors which affect the adsorption is depends upon the nature of adsorbent, nature of adsorbate, pressure and temperature. So these are the factors which affects your adsorbent. Okay, adsorption. So during adsorption, there is always a decrease in residual forces of the surface. That is, there is decrease in surface energy which appears as heat. So always adsorption. Okay, adsorption, it occurs as an exothermic process. Okay, exothermic process means what? Heat is involved. Okay, heat is given out. So during whenever adsorption is taking place, there will be decrease in the surface energy because of the residual decrease in the surface. Okay, there is a decrease in the residual forces of the surface. So because of this, there is decrease in surface energy. So always adsorption, it occurs as an exothermic process. So in other words, delta H of adsorption is always negative. So delta H is always negative because it occurs in a exothermic process. Okay. When a gas is adsorbed, so when you take gas molecules and it gets adsorbed, the freedom of movement of its molecule becomes restricted. So whenever you are taking gas molecules are considered and they are getting adsorbed, what happens? The freedom of the movement of the molecule, they are restricted, and these amounts to decrease in the entropy of the gas after adsorption. So whenever you are taking gas, so what happens? The freedom of movement of molecule become restricted, and thus what happened? There will be decrease in the entropy of the gas after the adsorption of the gas molecules. Okay. For a process to be spontaneous, means what? For a process to occur means what? Whenever certain reactants they react, so to give you a product, so that means what? The reaction is spontaneous. Okay, so for a process to be spontaneous, the thermodynamic requirement is that at a constant temperature and pressure, delta G must be negative. That is, there is decrease in the Gibbs energy. So always for any spontaneous reaction to proceed. So what is the condition? What is the thermodynamic requirement is that at constant temperature and pressure, always your Gibbs energy should be negative. Always your Gibbs energy should be negative. So this is the condition. So in adsorption process, your delta H will be always negative, delta S will be always negative, delta G will be always negative. Okay, so entropy, enthalpy, and Gibbs energy will be always negative in an adsorption process. So we'll see some questions now. So adsorption of gases on solid surface is generally exothermic because, go through the options. Yes. So adsorption of gases on solid surface is generally exothermic because, what is the reason? What happens to entropy? Yes, Rakshita, Damini, yes. So entropy decreases, right? So in adsorption, so we have seen in adsorption, what happens? So in adsorption, delta S will be negative. Okay. But since adsorption is spontaneous, adsorption is spontaneous, so delta H factor. Okay, so delta H factor also should be negative. Okay, so it must be a favorable. It must be favorable. That is, delta H should be negative. So adsorption of gases on a solid surface is generally exothermic because your delta H will be negative. That is entropy. What happens to entropy? Entropy decreases. Okay, entropy decreases. So which of the following gases is adsorbed most by activated charcoal? So which of the gases is following gases adsorbed more by the activated charcoal? Yes, when do we use activated charcoal? When do we use activated charcoal? Yes, most of you have answered it A. So A is the correct answer. That is carbon dioxide. Okay, so carbon dioxide, so activated, CO2 gas, it is easily liquidable gas. Okay, it is easily liquefiable gas. So hence it is absorbed most by charcoal. Okay, so it is, the gas which gets absorbed mostly by activated charcoal is CO2 because it is most easily liquefiable. Okay. So we'll go for the next one. Delta G, delta H, and delta S for adsorption of a gas on a solid adsorbent are respectively. So what are the this always for delta G, delta H, and delta S? Yes. Harshita, Damini, Kumar. Yes. The answer is C. So these are always negative. Okay. For adsorption of a gas on a solid surface. So delta G, delta H, and delta S are always negative. Yes. Good. Okay. So we'll go for the next one. Which one of the following substances adsorb hydrogen gas most strongly? So, which of the following substances adsorb hydrogen gas most strongly? Hydrogen gas. Okay, hydrogen gas. So, the answer is C. Okay, the answer is C, platinum black. Okay, so platinum black, it is a finely powdered. So hence what will happen to, if it is powder, what will happen to the surface area? Surface area will be more. So if the surface area is more, what will happen to the residual force? So residual force will be maximum. Okay, residual force will be maximum. So it is platinum black. It is what? It is a powdered. It is powdered. It is powdered. So what will happen? As it is powdered, so surface area will be more. Surface area will be more, and thus residual force will be maximum. So the answer is platinum black. Okay. So we'll go for the next one. I hope you're understanding the questions. So we'll go for the next one. So next is catalyst. Okay, what is a catalyst? What is a catalyst? What is the role of the catalyst? So catalyst is a substance when added to a reactant system increases the rate of the reaction without itself being consumed. So you can see this reaction. Okay, you can see the reaction. So here MnO2. MnO2 is acting as your catalyst. So what is the role of the catalyst? So whenever you are adding the catalyst to a reacting system, what it does, it increases the rate of reaction, okay, without itself being consumed. So it just alters the rate of the reaction. It just increases the rate of reaction instead being or it does not itself being consumed. Okay, it does not gets involved in the reaction. Only it alters or it increases the rate of the reaction. So hence, what is a catalyst doing? It is if it is increasing the rate of reaction, that means there is decrease in the activation and energy. So catalyst, what it does, it decreases the activation energy. So this thus the phenomena of increasing the rate of reaction with the help of catalyst is known as catalysis. Okay. So what is catalysis? The phenomena of increasing the rate of reaction with the help of catalyst is called as catalysis. Now, there are types of catalyst. So what is a positive catalyst? Whenever it increases the rate of reaction. Okay, whenever, so the first is positive catalyst. What is positive catalyst? So positive catalyst, it increases the rate of reaction. Okay, it increases the rate of reaction. Example, decomposition of KClO3 in the presence of MnO2 as a catalyst. Okay, what is negative catalyst? Negative catalyst, it decreases the rate of reaction. For example, so oxidation of sodium sulfide by air in the presence of alcohol. So types of catalyst we are seeing. So we'll go for the next one. Auto catalyst. What is the role of auto? Auto means what? Okay, so one of the product in the reactant, it acts as a catalyst. So whenever the reaction is occurring, so one of the products itself in the reaction, it acts as a catalyst. So the oxidation of oxalic acid by acidified KMnO4, that is potassium permanganate, is accelerated due to the presence of Mn+2 ions which are found during the reaction. Those Mn+2 ions, they act as a autocatalyst. So this is the example. So remember the example. So autocatalyst means what? One of the product, it acts as a catalyst. So the oxidation of oxalic acid by acidified KMnO4, your Mn+2, they act as a autocatalyst. So this is the example. Next, depending upon the phase of catalyst and reaction mixture. So depending upon the phase of catalyst and reaction mixture, so the first is homogeneous catalyst. What do you mean by homogeneous catalyst? That reactant and the catalyst are in the same phase. So when you are reactant, so you can see here, okay, so this is your reactant. So these are in which phase? Gaseous phase. Your catalyst is also in gaseous phase, right? So whenever your reactant and the catalyst are in same phase, then they are said to be homogeneous. What they are said to be? Homogeneous. Next is what? Heterogeneous. What do you mean by heterogeneous? When reactant and the catalyst are in different phase. So you can see here, reactants are in gaseous phase and your catalyst is in solid phase. So reactant and catalyst, when they are in different phase, then they are said to be heterogeneous catalyst. Okay. Next is catalytic promoters. What do you mean by catalytic promoters? Substance which can increase the activity of catalyst. Okay, so whenever, so you are adding, so there is a presence of catalyst in the reaction. Okay, so there are reactant, you have added a catalyst, but still you want, so there is something called as catalytic promoter. Means what? In the presence of catalyst, you are adding a promoter. So your molybdenum, okay, MO, you can see here. So this is acting as a promoter. So what is the role of this catalytic promoter? So this increases the activity of the catalyst. So it enhances the activity of catalyst. Okay. So promoters. So catalytic promoters are what? So these are the substances which can increase the activity of catalyst. So here, which is the promoter? Molybdenum. Okay. So we'll go for the next one. So catalytic poisons or anti-catalyst or catalyst inhibitor. What do you mean by now? Inhibitor. Okay, catalyst inhibitor. So as promoters are used for increasing the activity of catalyst, there is something called as inhibitors or poisons or anti-catalyst. So what it does, it does reverse of catalyst. Okay, promoters. That is the substances which can decrease the activity of catalyst. Okay. So which can decrease the activity of catalyst, then they are said to be a catalytic poison or anti-catalyst or catalyst inhibitor. So here, which is the poison? So it is carbon monoxide or H2S. Okay. So this, it decreases the activity of catalyst. Okay. So remember this definitions, remember these points. So next is enzyme catalysis. What do you mean by enzyme catalysis? So biological reactions. Okay, you know some of the biological reactions. So these biological reactions, they are catalyzed by some enzymes. So these enzymes are termed as biochemical catalysts. So certain reactions, that is biochemical reactions, they involve some they are catalyzed by some enzymes. Okay, you can see this example, right? Your hydrolysis of sucrose. Okay, hydrolysis of sucrose in the presence of the invertase. Okay, invertase is the enzyme used, so it gives you glucose and fructose, right? So here, so you can see here, so numerous, so what is enzyme catalysis? That is biological reactions are catalyzed by enzymes. So the enzymes are termed as biochemical catalysts. Okay, next. So which is an enzyme? It is invertase. So we'll see some questions now. So which of the following types of metals form the most efficient catalyst? Yes, which of the following will following types of metals form the most efficient catalyst? Yes, they are transition metals. Yes, most of you have answered it right. It is transition metals. So transition metals, they can provide what? They can provide surface for absorption of reactants. Okay, they can provide surface. They can provide surface for the absorption okay, of reactants. Also, they provide low energy path for a reaction to take place by the change of oxidation state. So this is a reason. So transition metals. So the answer is transition metals. An example for autocatalysis is what is the example for autocatalysis? Autocatalysis in which the uh, product itself act as a catalyst. Yes, which is the example for autocatalyst? We have seen this autocatalyst. Yes, Kumar. It is D. Yes, Harshita, Gurusit. Yes, it is D. Oxidation of oxalic acid by acidified KMnO4. Okay, oxidation of oxalic acid by acidified KMnO4. So this is an example for autocatalysis. So 2SO2 gas plus O2 gas in the presence of V2O5, okay, giving you 2SO3 gas. So what type of catalysis it is? Homogeneous, neutralization, irreversible, or heterogeneous? Yes, Lakshmi, Kumar. It is what? It is, you can see, it is what? It is gaseous and this is solid. So it is heterogeneous catalysis. Okay, so heterogeneous catalysis means what? Both the reactants and the catalyst are in different phase. So they are in solid and gaseous phase. Yes, most of you are absolutely right. So we'll go for the next one. What are colloids? Okay, so what are colloids? Yes. So what are colloids? So colloids are these are the, okay, you can see this is a colloidal system. Okay, so what is a colloidal? So here a substance is said to be in the colloidal state if it acquires a, okay, it requires a particle size which is ranging between 1 nanometer to 10 raised to 3 nanometer on treatment with a solvent. Okay, so what are colloids? So you can see what there is a solution. Okay, so one is a dispersion medium and one is a disperse phase. So what you are doing, you have added starch in a beaker. So a beaker containing water, it consists of what? It consists of water. So this liquid is called as a dispersion medium, and the solid particles, okay, granules which are there inside it, it is called as a disperse phase. Okay, your starch is added in the water. Okay, a beaker consisting of water. So dispersion, which is represented as an intermediate. So this dispersion, okay, it represents the as an intermediate between the true solution and suspension. Okay, it represents as an intermediate mixture between a true solution as an suspension. Okay. So colloidal dispersion, there are two phase systems which are involved. So the first is your disperse phase and second is your dispersion medium. So what is disperse phase? Disperse phase is analogous to solute, okay, and dispersion. And these here the particles are being dispersed. Okay, disperse phase means what? Here it is analogous to solute in the solution, and these are being, the particles are being dispersed. In dispersion medium, it is analogous to solvent. Okay, it is analogous to solvent in the ordinary solution. So the medium in which disperse phase exists. So the medium, okay, in the last slide we have seen the diagram, the beaker. Okay, so the solution which is present, so that it represents as that of solvent. So it is analogous to that of solvent. Okay, so the medium in which the dispersed phase exists is called as your dispersion medium, and the particles are being dispersed, okay, in your dispersed phase. So the colloidal dispersion out of two phase. So that is dispersed phase and your dispersion medium. So this your dispersed phase, it is discontinuous phase, okay, and dispersion medium, it is a continuous phase. It is a continuous phase. So now we'll see the classification of colloids. So there are two more common methods of classifications are, so the first, it is based on the nature of interaction between the dispersed phase and the dispersion medium. And next is based on the type of particles of the dispersed phase. Okay, so first is lyophilic sol. So based on the nature of interaction between the dispersed phase and dispersion medium, they are classified into two types, lyophilic sols and lyophobic sols. So what do you mean by lyophilic sols? They are liquid loving, and lyophobic sols, they are liquid hating. Okay, so so these are classified based on what? They are classified based on the nature of interaction between the dispersed phase and the dispersion medium. So now we'll see we'll see the differences between lyophobic and lyophilic colloids. What do you mean by lyophobic? Lyophobic means water hating, lyophilic means water loving. Okay. So lyophilic sols, there is a strong affinity between the dispersed phase and the dispersion medium. Lyophobic sols, there is a low affinity between the dispersed phase and the dispersion medium. On shaking with the dispersion medium, they directly form the colloidal sol. So lyophilic sols on shaking. So when you shake it with dispersion medium, they directly form the colloidal sol. And your lyophobic, so these are called as intrinsic colloids. These are called as what? They are called as intrinsic colloids. So these can be prepared easily. Okay, lyophilic sols can be prepared easily. Lyophobic sols, they can be prepared by indirect method only. Okay, so here it is on shaking you can prepare your colloidal sol, that is lyophilic sol, but on lyophobic they cannot be prepared easily. They have to be prepared by indirect method. So these are called as extrinsic colloids. They are difficult to prepare. Okay, so as they are difficult to prepare, they are called as extrinsic colloid. The particles of sol migrate towards the anode or cathode in an electric field. So if you apply an electric field, so the particles of sols, they will migrate to either, it will migrate towards the anode or cathode. In lyophobic sols, the sol particles may or may not migrate in an electric field. So in lyophilic sol, the solids obtained after evaporation may be reconverted to form the sol by simply shaking them with the dispersion medium. So if the solids after evaporation, if they are turned into solids, so what you can convert them back to sol by simply shaking it with the dispersion medium. And lyophobic sols, the precipitated mass cannot be brought back into the colloidal state by simply shaking them with the dispersion medium. Okay, so lyophilic sol, if they are converted into solids, so if you shake them in the with dispersion medium, it will be easily they can be you can reconvert them back to sols. But lyophobic, the precipitate mass cannot be brought back into its colloidal state by simply shaking. Okay. So hence, because of these, lyophilic sols are called as reversible, because the solids can be reconverted on shaking to sols. So it is called as reversible. Lyophobic, hence they are called as irreversible. Okay, so these two lyophilic sols, they are stable, and lyophobic sols, they are unstable. Okay, so the surface tension of the sol is lower than that of the dispersion medium in lyophilic sol, and in lyophobic sol, the surface tension of the sol is same as that of the dispersion medium. So these are some of the differences, okay, between the lyophilic sols and lyophobic sols. Few more. The viscosity of the sol is higher than that of the dispersion medium in lyophilic sol, and lyophobic sol, the viscosity of the sol is the same as that of the dispersion medium. So for example, lyophilic sol examples are gum, starch, gelatin, rubber, etc. Lyophobic sol, metal sulfide sol, and metal sol. So these are the examples of lyophobic and lyophilic sols. So we'll solve some questions Which of the following is correct for lyophilic soul? Yes, which of the following is correct for lyophilic soul? So we have seen the, yes, yes, they are self stabilized. Okay, they are self stabilized. So lyophilic souls, they are self-stabilized due to solvation. Okay, so the answer is it is self-stabilized. They are stable. Lyophilic soul. Okay. The stability of lyophobic collide is due to the stability of lyophobic soul collide is due to, it is due to the charge on the particles. Okay, remember this. It is due to the charge on the particles. So the stability of the lyophobic collide is due to the charge of the particles. So butter is a collide containing, what does butter consist of? Yes, butter is a collide containing. It is C. Okay, it is C, water disposed in fat. Okay, it is water in fat type. Okay, it is water in fat type. That is, water is dispersed type and fat is a dispersion medium. Okay, so the answer is C. Answer is C. So we'll see the classification of colloids. So based on the nature of interaction between dispersion phase and dispersion medium, we have seen they are classified into lyophilic and lyophobic. Now, based on the type of particle of dispersed phase, they are divided into micromolecules, multimolecular colloids, okay, and associated colloids. So we'll see now first with multimolecular colloids. What are multimolecular colloids? So multimolecular colloids, for example, starch in water. Okay, so you have taken a beaker, you have added water. So these are what small starch molecules. Okay. So what happens? So these starch molecules, they will aggregate. Okay. They will come closer and they will form a big one molecule. Okay. One molecule. So size of the starch molecule is increased and it comes in the range of 1 nanometer to 10 raised to 3 nanometer. Okay. So forming a colloid. So all the small granules, they come together or they aggregate to become a one colloid. It forms a one colloid. So this is called as multimolecular collide. So this is called as multimolecular collide. So what is multimolecular collide? They are formed by the aggregation of a large number of atoms or molecules which are generally having diameters in the colloidal range. So all the small molecules, okay, which were large in number in the beaker, so all they get aggregated. So they all come close together, forming a one forming a colloid. That is, it is called as multimolecular colloid. Okay. So examples, what are the examples of multimolecular colloids? Souls of gold, then sulfur, etc. So these atoms or molecules are held together by weak van der Waals forces. So next we'll see, so second type. So next we'll see the macromolecular colloids. Okay, what are macromolecular colloids? So macromolecular colloids. So these macromolecular solutions are through solution consisting of single macromolecules. Okay, they are consisting of single. They consisting of single macromolecules so large that they fall into the colloidal range. Okay. So example, polymers like rubber, nylon, polythene, starch, cellulose, protein, enzyme, etc. So these are the examples of micromolecular colloids. So these substances, when dissolved in suitable liquid, they directly form the colloidal solution. Okay. So in macromolecular colloids, they containing polymers. Some polymeric species themselves form ions and hence can migrate in an electric field. Such macromolecules, so such macromolecules which themselves, when they form ions and when they migrate in an electric field, then they are called as colloidal electrolytes. What they are called? They are called as colloidal electrolytes. So next we'll see associated macromolecules. Okay. Associated colloids. So what are associated colloids? Certain substances when dissolved in a medium at low concentration behave as normal strong electrolyte. Okay. But at higher concentration, they exhibit colloidal state properties due to the formation of aggregated particles and are called as associated colloids. So certain substances, when dissolved in medium at a lower concentration, they behave as what? They behave as a normal strong electrolytes. At higher concentration, they exhibit colloidal state properties. But at higher concentration, what they do? They behave as a colloidal state properties due to the formation of aggregated particles, and they are such are called as associated colloids. They are called as associated colloids. So these aggregated particles, okay, those formed are called as what? They are called as micelles. The aggregated particles, okay, they are called as micelles. So most common associated colloids are formed by soaps and detergents. So the associated colloids most formed are by soaps and detergent. Okay, so micelle formation takes place above at a particular temperature, which is called as the Kraft temperature. Okay, and at a particular concentration that is called as critical micelle concentration, that is CMC. So micelle formation, it takes place at particular temperature called as a Kraft temperature and particular concentration called as a critical micelle concentration. So questions. An example of an associated colloid is, yes, what is an example for an associated colloid? What is an example for an associated colloid? Associated colloid, yes, it is a soap solution. So soap solution is a example for associated colloid. Sulfur sol is a type of, yes, we have seen the example. What is sulfur sol? What is it? It is a multimolecular colloid, macromolecular colloid. Yes, what it is? Multimolecular or macromolecular? Yes, it is a multimolecular colloid. Yes. So sulfur sol contains large aggregates of sulfur molecules. So it is an example of multimolecular colloid. The solution of rubber in benzene is an example for, okay, the solution of rubber in benzene is an example for, yes, it is example for what? Rubber in benzene. Yes, Sinchana, Harshita, no, Damini. Okay, it is D. It is macromolecular because the particle size is relatively large. The particle size is relatively large. So it is a macromolecule. Okay, molecular colloid. So next we'll see preparation of colloid sols. So dispersion method and condensation method. So dispersion method, it involves the breaking down of bigger particles into colloidal particles. So this is done by following methods, that is mechanical dispersion, electrodispersion, that is Bradick-Ars method, and peptization. Okay. So what is mechanical dispersion? Particles are grounded to colloidal size and are then dispersed in medium. So mechanical dispersion is nothing but particles are ground. Okay, they are ground to colloidal particles and then they are dispersed in liquid. So, for example, ink. Okay, ink is the example for mechanical dispersion. Next is electrode disintegration, that is Bredik's arc method. So what is Bredik's arc method? So it is a this method is employed to prepare colloidal solutions of metals. For example, gold, silver, platinum. So you can make the colloidal solutions of metals. Okay. So we'll see Bredik's arc method. So this, so you can see the diagram. Okay, so this is ice. So a beaker is taken, ice is placed, then another beaker is taken in which water is placed. Then two metal electrodes are there. There is a arc. Okay, so these two metal electrodes are dipped in water. That is a cold water bath. So the apparatus consists of metal electrodes which are dipped in cold water bath. So this method involves what? You're passing the electric current through the electrodes which are made up of desired metals. So the metal is suspended into a water, okay, a trough of water which is kept cool by surrounding ice. So due to the intense heat of the arc, what happens? The metal changes into vapors which then condense to form the colloidal particles. So this is Bredik's arc method. Okay. So water is placed. So beside water, what is kept? Ice is kept. Why ice is kept? So that the water is kept cooled. Okay. So due to intense heat, so due to the intense heat of the arc, what happens? The metal vapor changes into vapors which condense to form the colloidal particles. Next is peptization. What is peptization? It is a process of converting a freshly precipitated substance into colloidal particles by shaking with a suitable electrolyte. So the added electrolyte is called as peptizing agent. So what you are doing, you are converting a freshly precipitated substance into a colloidal particles by shaking with a suitable electrolyte. So this added electrolyte is called as what? It is called as peptizing agent. So example, a freshly prepared precipitate of AgI can be converted into colloidal state by stirring it with silver nitrate solution. So this is called as peptization. So preparation of colloidal sols. So we have seen disintegration method. So aggregation method. What do you mean by aggregation method? So this involves the joining together of large number of smaller particles to form colloidal particles. So how it is formed? It is formed by chemical methods. Okay. So chemical methods you can do by reduction, by oxidation, and by hydrolysis. So certain colloidal sols can be prepared. So gold sols, first by reduction, we are preparing the gold sols. By oxidation, colloidal sols, and by hydrolysis, we have prepared a ferric. Okay, ferric hydroxide colloidal sols. Okay, so these are certain chemical methods. So freshly prepared precipitates sometimes get converted to colloidal solution by, yes, freshly prepared precipitate sometimes gets converted to colloidal solution by, yes, it is by peptization. Yes, it is by peptization. Good. So we'll go for the next one. Bredik's arc method for the preparation of metallic sol involves. So what does Bredik's arc method involves for the preparation of metallic sols? Yes, Kumar. It involves dispersion as well as condensation. So in Bredik's arc method, as spark is passed to the metal strips dipped in the ice and cold bath, there is involvement of what? Dispersion as well as the condensation. So the answer is what? It is C. So how do you purify the colloidal sols? The process of reducing. So whenever you, what is purification? Purification is nothing but you are removing the impurities. You are reducing the impurities to a minimum desired level. Then it is said to be a purification. Okay. So how you can purify your colloidal sols? So first is dialysis. Okay. You can do dialysis to. Okay. So you can do dialysis to purify your colloidal source. So what is dialysis? It is a process of separating the particles of colloids from those of the crystalloids by diffusion of the mixture through a parchment paper or animal membrane. So this is dialysis. Okay, you are separating the particles of colloids from those of the crystalloids by diffusion of the mixture through a parchment paper or animal membrane. So this is the process of dialysis. Next is electrolysis. Electrolysis, in this method, the movement of ions across the membrane. Okay, it occurs, and that is what you are applying the electric current to two electrodes. So if you apply the electric current to two electrodes, thus the movement of ions across the movement occurs. So electrodialysis. So this electrodialysis is a very fast method. Okay. Next is ultrafiltration. So this is a process of separating the particles of colloids from those of the crystalloids by filtration. Okay, through a ultrafilter paper. Through a ultrafilter paper. So what is ultrafilter paper? It is obtained by treating a ordinary filter paper with collodion or gelatin solution to narrow down the pores suitably. Okay, so this is called as ultra filter paper. The sole is poured over the ultra filter, which permits solution of electrolyte to pass through but retains the colloidal particles. So this is the principle behind the ultra filtration. Okay. So if you take a torch and you pass through a through solution, so you will not be able to see the light. Okay, but if you pass your torch through a colloidal solution, then the path of the light becomes visible. Why is it so? It occurs due to the scattering of light by colloidal particles. Okay, so it depends upon the property called as scattering of light. Now, what is the scattering of light? So scattering of light by colloidal particles and making the path of light visible to the dispersion is nothing but it is called as the Tyndall effect. It is called as what? It is Tyndall effect. This Tyndall effect was given by John Tyndall. Okay, it was given by John Tyndall. So kinetic property, when colloidal solution was observed under microscope, the colloidal particles undergo ceaseless random motion in all direction over a large area. So so it undergoes a zigzag motion like this. Okay, you can see the kinetic energy. So this was given. So this was given by Robert Braun. Okay, what he could see that the colloidal particles, they were undergoing a random motion in all the directions over a large area. So this motion of dispersed phase particle is called as Brownian movement. This is called as Brownian movement. Okay. So why such movement occurs? Now, why such movement occurs? The colloidal particles, they exhibit such non-stop continuous motions. Okay, they because they are constantly bombarded by a molecules of dispersion medium. So why such Brownian motion, or why such colloidal particles exhibit non-stop continuous motion? Because they are constantly bombarded by molecules of dispersion medium. So you can see here. Okay, so because of this, there is non-stop continuous motion which is occurring, which is called as Brownian movement. So all the particles in given dispersion medium, they carry either positive or same charge or negative. So the particles, what happen? They repel each other and do not come close together to form large particle. So that will precipitate out. So this is the reason behind the stability of colloids. Okay. So colloidal particles positively charged, then you have to use a negative electrode. If they are negatively charged, you have to use a positive electrode. So electric field, it is used for electrophoresis as well as the electroosmosis. Okay, in electrophoresis, what happens? Dispersed phase will migrate and in electroosmosis, dispersion medium will migrate. So the movement, so this is a U-shaped tube. Okay, so movement of colloidal. So this is a electrophoresis method. The movement of colloidal particles either towards the anode or cathode under the influence of electric field is called as electrophoresis. So the movement of colloidal particles, either if it moves to anode or cathode under the presence or influence of electric field, then it is called as electrophoresis. So migration of colloidal particles under the effect of an electric field is known as, yes, what it is known as? What it is known as? Yes, it is known as B. It is known as B, electrophoresis. It is known as B, electrophoresis, right? Tyndall effect in colloidal solution is due to, why do we see Tyndall effect in colloidal solution? Why? Yes, it is due to scattering of light. Yes, good. It is due to scattering of light. The color of sky is due to, color of sky is blue. Why? What is the reason? What is the reason? It is due to, yes, C. Akash, yes. It is C. That is what? It is due to scattering of light. It is due to scattering of light. Okay. So the answer is C. The answer is C. Next. Brownian movement is due to, Brownian movement is due to, why the Brownian movement you can see? It is due to what? It is due to, yes, it is due to impact of molecules of dispersion medium on the colloidal particles. Okay, it is due to dispersion medium of colloidal particles. The answer is what? The answer is C. Answer is C. So coagulation, what do you mean by coagulation? It is defined as a precipitation of colloids by removal of charge associated with the colloidal particles. So lyophobic colloid, it is obtained by removal of charge, and lyophilic colloid, it is obtained by removal of charge and layer of medium. Okay, so this is coagulation. Then flocculation value, the minimum concentration of an electrolyte which is required to cause the coagulation of a sol is known as coagulation value. So it is expressed in what? It is expressed in millimoles per liter. Okay, it is expressed. So coagulation value is inversely proportional to coagulation power. The precipitation action of ions of an electrolyte, it depends upon the sign of the charge and valence of the ions. So what type of electrol is used? So the effects of these factors on the coagulation. So this effect, it factors of on the coagulation of colloidal particles was stated by S. Ketchell and Sir William Hardy. So based on this, they gave their law. Okay, that is rules of Ketchell-Hardy rules. What were the rules? That it's okay, ions of opposite sign to those present on the surface of the particle cause the precipitation of particles. So this was Ketchell-Hardy rules. So the precipitation power of an electrolyte increases very rapidly with an increase in the valence of an anion or cation. So thus the precipitation power of ion decreases in the order. So more the ion, okay, so less will be the this. So Ag plus Al plus 3 is more, it is having more precipitation power, okay, as compared to that of Cl. So it goes on increasing, right? Al plus 3 is more as compared to Mg plus 2, then Na plus, and here you can see PO4 minus 3 has more than SO4 minus 2, and then Cl minus. So more the electric power, okay, more the charge, more will be the precipitating power. So it decreases in this order. So protection of colloids, the process of protecting the lyophobic colloidal source from precipitation by the electrolyte due to previous addition of some lyophilic colloids are known as protective colloids. What is gold number? The minimum number of milligrams of the protective colloids which are required to just prevent the coagulation of a 10 ml of a given gold sol when 1 ml of 10% solution of sodium chloride is added to it is called as the gold number. Then what are emulsions? Emulsions are the colloidal systems in which both the dispersed phase and the dispersion medium are liquids. So these are stabilized. How they are stabilized? They are stabilized by addition of substances called as emulsifiers. Okay, they are stabilized by adding of substance called as emulsifiers or emulsifying agents. So based upon the nature of dispersed phase, the emulsion are classified into two, that is oil in water and water in oil. Okay, what is a de-emulsification? So emulsions can be converted into two separate liquids by heating, centrifuging or freezing. So this process is called as a de-emulsification. So what is emulsifier? Yes, what is emulsifier? Emulsifier is a substance which is, emulsifier is a substance which yes, it stabilizes the emulsion. Yes, good. So it stabilizes the emulsion. Protective power of a lyophilic sol is expressed in terms of. So protective power of a lyophilic sol is expressed in terms of what? It is expressed in terms of gold number. Okay, remember this? Yes, it is expressed in terms of gold number because colloidal formed has a liquid-like appearance. Okay, so protective power of a lyophilic sol is expressed in terms of gold number. Then a colloidal solution may be coagulated by. Yes, how does a colloidal solution can be coagulated? By. Yes, by. Yes, by all of the above. So a colloidal solution may be coagulated by adding electrolyte, heating, by adding oppositely charged salt. Okay, so all of the above. Alum is a water purifier because it contains alum. It is as it acts as a water purifier. So why it acts as a water purifier? Yes, it coagulates the impurities. So okay, Al+3 of alum. So Al+3 of alum, it coagulates the negatively charged colloidal impurities of water and it purifies it. Okay, so it coagulates the impurities. So the last question, when a river enters the sea, a delta is formed. Formation of delta is due to, when a river enters sea, a delta is formed. Formation of delta is due to, yes, it is due to coagulation. Okay, it is due to coagulation. Salts in seawater, they coagulate the colloidal particles present in the river water. Okay, so coagulation. So when a river enters the sea, delta is formed. It is due to coagulation because salts in seawater, they coagulate to form the colloidal particles, okay, which is present in the river water. So this completes your chapter, okay, surface chemistry. So I hope you have understood today's session. Yes. So we'll stop it for today. So we'll continue in the next class. Thank you.
Thank you, ma'am.